Hi there everyone, Cody here. So there's been a lot of buzz lately about the EmDrive, and so I've decided to take another look at it. After more NASA testing, it appears that the device does seem to somehow work. So in this video I will try to make some sense of this. Disclaimer, I failed multivariate calculus and I do not have access to the actual research that NASA's done, so most of my data comes from what I can find on Google, and I'm going to stay away from advanced math as much as I can. I've made a little stand-in model for the EmDrive composed of a capacitor for power and a headlight representing the actual drive. The capacitor is charged with 6,000 joules of electrical energy. My EmDrive consumes 8 amps at 12 volts, so that's about 100 watts. The drive-capacitor combination weighs approximately 1 kilogram. It takes 2 minutes to discharge the capacitor to less than 1 volt. As the capacitor voltage drops, the power available to the drive also drops, and I'm approximating this curve as a straight line. If we assume the EmDrive puts out 50 newtons of thrust per kilowatt, a value I've been given by some sources, we should see 5 newtons going into this device, which will go to zero over a 2-minute period, giving a total of 300 newton seconds of impulse. This should move the craft from 0 to 300 meters per second as it gains 300 joules of energy. Dividing 300 by 6,000 gives us a 5% efficiency in converting electrical energy into kinetic energy. This seems totally fine and would not violate conservation of energy since we are putting in way more than we're getting out, at least as far as we can tell. So to check ourselves, let's try the math with the craft starting at, say, 100 meters per second instead of 0. From the craft's perspective, it's the same as if it were not moving. Speed is relative. However, this time the 5 Newton force would now be applied over a much greater distance, therefore more work is done and the device would gain 345,000 joules. We are getting out nearly 60 times the energy that we put in. A conventional rocket motor producing 5 newtons of thrust would also produce the vastly increased amount of work, and any Kerbal Space Program player would know this as the Oberth effect. Rockets become more efficient if you fire them when you're already moving very quickly. However, with a rocket, the extra energy comes from the fuel, which has a lot of mass, and that mass had to be accelerated up to your starting velocity. The extra energy needed to accelerate that fuel is then added to the spacecraft when the fuel is burned and thrown overboard. However, in this case, since there is no reaction mass being thrown off, it does violate physics. If this was true that the device could produce that much thrust for the amount of input, you could put it on the end of a long arm attached to a pivot with a generator, which would supply the energy to run the EmDrive, and it would create infinite energy. Obviously, then, the EmDrive must not work, because you cannot, according to well-tested laws of physics, create energy from nothing. In fact, this is almost as absurd as expecting to get infinite energy by plugging a power strip into itself. But NASA seems to have proved that it is producing thrust, so after a little bit more digging, I found a few sources for the number that NASA got being closer to 1.2 micronewtons per kilowatt. Way smaller, but still a usable amount of thrust. So let's see if that makes more sense. Given our power consumption, we should get 0.12 micronewtons of thrust, and with our setup, that would come out to 7.2 micronewton seconds of impulse for a full capacitor charge. This would accelerate the craft from rest to 0.007 millimeters per second, giving it a total of 2.6 times 10 to the negative 11 joules of kinetic energy, for an efficiency of, a trillionth of a percent. A tiny amount, but it's still there, and so far it doesn't seem to break physics since more energy is going in than coming out. Way more, in fact. Now let's ramp up the starting speed to 200 million meters per second. This is insanely fast, but relativistic effects should be still sort of small since it's only 60% the speed of light. To get it going this fast, maybe we drop it into a tight orbit around a black hole or a neutron star. It doesn't matter, the laws of physics should be the same everywhere. The craft now accelerates from 200 million meters per second to 200 millimeters per second plus 0.0072 millimeters per second. Using the kinetic energy equation and plugging these numbers into my calculator, we find that the calculator can't handle it. But once I crunch the numbers by hand, we find that this gives us an increase of 1,400 joules, for an energy efficiency of 23%. Way more, and it is not above 100, so it still does make sense. So far we haven't proven that it violates physics, even when put in an extreme situation. But we still don't have a mechanism for how it would be producing that thrust. Well, what about what has been staring us in the face all along? My little device here that I've made to recreate the EmDrive does actually produce some thrust because it's putting out light. In fact, my Does Light Push video confirmed that photons, which have no rest mass but have relativistic mass and therefore momentum when they're traveling, can transfer energy to an object when they bounce off of it. So plugging the numbers into the equation, force equals watts divided by speed of light, we get 0.3 micronewtons of thrust. Wait, that's more than the EmDrive got. Remember, our model using NASA numbers got 0.12 micronewtons. That means our light could get 2.5 times more thrust than the EmDrive of the same wattage. Considering that the energy they put into the device must go somewhere, and probably ends up as heat, I'm very suspicious that the effect we're seeing is really just radiation pressure. I do, however, find it hard to believe that NASA researchers would overlook such an obvious explanation, so perhaps that will be included in the paper that is coming out, or they've already taken account of that, which some sources say they did. In which case this would be an entirely new effect, perhaps pushing on the quantum foam or photon coupling or whatever, but it would still be an exciting discovery. However, I do not believe it is one that will allow us to send probes to other stars. In fact, I would argue that any device converting electrical energy into kinetic energy, no matter the mechanism, wouldn't actually be reactionless. Because as the capacitors, batteries, or whatever were drained of energy in order to run the drive, they would also be losing mass. Because energy equals mass times the speed of light squared. This brings us back to how rockets work, and we know that rockets do indeed work. As someone who believes in the scientific method, I will stay open to the possibility that the laws of physics could be wrong. However, I am so confident that the laws of physics will hold that if any device is capable of producing more than a newton of thrust for less than 300 million watts of power without throwing something else overboard, or is capable of maneuvering itself in space better than a solar cell spacecraft could, then I will actually eat this hat. I'm not kidding. If such a discovery is made, I will be so excited that I will be perfectly happy munching down on a little bit of cotton. So I hope you guys enjoyed the little bit different video style for today. It didn't turn out quite as well as I had hoped, but it is something I've been wanting to try out for a while. If you guys would like to see a little bit better video, my friend Isaac Arthur put out a video on a similar topic on his channel earlier today. So if you like really long, in-depth science videos, I would definitely recommend going to check him out. The links are in the description. Hope you all enjoyed. I'll see you next time.